few more examples of being able to find the areas bound by some polar curves. This time we want to try to find the area bound inside the lemacon r equals 2 plus 3 sine of theta, right? So it doesn't necessarily tell us that it wants any specific area, like for instance, inside one petal, like we did in the previous example. So if it doesn't necessarily say bounds, then what you just need to do is figure out how long it takes to do a complete revolution to complete the graph. So we're going to take a look at the graph of this. And if we look at the graph of 2 plus 3 sine theta, or one second, let me make sure it was the other way out, 2 plus 3 sine theta. Right. This is the graph that we get, right? And what I'm going to do is I'm just going to go from 0 to pi just to make sure that it should go from 0 to 2 pi. Now notice when I go from 0 to pi, it cuts off this bottom part, okay? So realistically, we do want the 2 in there to get the entire area of the lemacon, all right? So, and then of course, another way to do this is to go from pi halves just to see what's going on with it. So that's what I would do, is just to kind of see what's going on with this, if you're going in 2 complete revolutions or not. Okay, so this is going to be 2 pi, right? And now what we're going to do is we're going to go ahead and just set up our interval. Right, so this is 2 pi, and it does ask us to sketch the graph, so I'm going to do my best to sketch it. As you guys know, not all that great at this. So we're going to have an inner loop. Okay, so we have like a circle inside of here. All right, so, and then we're going to have a little dimple out here, another dimple, and then it's going to look something like this. Okay, and the area we want is everything that's inside of here. Okay, and so to figure that out, we're just going to use our formula. A equals 1/2 integral from a to b of r square d theta. Or in this case, we're going to get 1/2 integral from 0 to 2 pi. And we're just going to take that 2 plus 3 sine theta. We're going to square it. Now, of course, we're going to have to use the FOIL on this. Okay, so we're going to end up with 1/2 integral from 0 to 2 pi of the quantity 2 plus 6 sine theta plus 9 sine square theta d theta. All right, and again, to be able to get that, just take 2 plus 3 sine theta and multiply it out by 2 plus 3 sine theta. Okay, so it's not just going to be 4 plus 9 sine squared theta. We have to make sure we do the FOIL for that. Now, we also want to simplify the 9 sine square, and we're going to use our power reducing formula. Okay, so again, we need to get used to these because they do show up quite frequently in these sorts of examples. And so we're going to end up with S, or I'm sorry, power reducing formula is sine square of theta is going to be 1/2 minus 1/2 cos 2 theta. Right? And so finally, we can rewrite this as 1/2 the integral from 0 to 2 pi. And we're going to have 2 plus 6 sine theta plus 9/2 minus 9/2 cos 2 theta. And then d theta. And of course, we could go ahead, we could combine the 9/2 with the 2, all right, and then also distribute the 1/2 to everything. And so if we do that, we know that 9/2 and 2 is going to be 13/2, right? And then we can distribute the 1/2 to everything. So we're looking at an integral from 0 to 2 pi of 13/4 plus 3 sine of theta minus 9/4 cos of 2 theta. All right, d theta. And so finally, now what we can do is we could just distribute or integrate term by term, right, and then be done with this. So integral of 13/4 with respect to theta is 13/4 theta. Antiderivative of 3 sine of theta is going to be -3 cos of theta. And then finally, we're going to end up with minus 9/8 sine of 2 theta. All right, so that's going to range from 0 to 2 pi. Okay. So now we're going to substitute our 2 pi back in, and we're going to substitute 0 back in. And the good news is some good things are going to happen with this. So we're going to have 13/4 times 2 pi minus 3 cos 2 pi minus 9/8 sine of 2 times 2 pi minus the quantity of 13/4 times 0 minus 3 cos of 0 minus 9/8 sine 2 times 0. All right. So at this point, there is a little bit of good news. Okay, 3/4 or 13/4 times 0 is 0. And then 13/4 times 2 pi, that's going to be 13 pi over 2. The cosine of 2 pi is going to be equal to 1. The cosine of 0 is equal to 1. And notice that we have a -3 minus a -3. So those are going to be opposites, and they're going to cancel out. And then finally, we get the sine of 4 pi. And the sine of 4 pi is the same thing as the sine of 2 pi, which is the same thing as sine of 0. All right, which is going to be 0. And of course, you can check this in your calculator if you don't believe me. And then over here, we get the sine of 0, which is 0. So ultimately, we just end up with 13 pi over 2 for our area. Okay. All right. So we're going to take a look at a few more of these in the next videos. But for right now, just make sure that you understand how to set these up, the importance of using the graph, and then finally also making sure that we understand as we're going through this, just making sure that we understand how to go through and use our power reducing formulas and our techniques of integration to be able to evaluate these.